Okay, everyone, so we are at 80%. I'm going to close it here in about 20 seconds. Get the last of those in. Okay, so, and the person who just private messaged me, you may want to private message Aziz instead, because he'll be able to answer you that. Okay, so let me share the results, and then let me know if Aziz doesn't answer it, because I'll get back to you. All right, 62% of you said D. D is absolutely the correct answer. Like, phenomenal job, good job. Maybe it's because, you've been working on the assignment, and the assignment has something kind of similar here. But either way, that's phenomenal, right? That's a really good sign of the learning. And notably, I think, Curdy, you asked whether or not the sums always start at 0. And you'll notice that D here is the correct answer, and the sum here actually starts with D, right? So that's kind of an important thing, that there's a difference there. So this was question 2. Okay, so question 2. And again, so we've got an annuity, compounds interest rate R at the end of the month. So compounding at R at the end of the month. And I really do want to make sure here, you remember at the beginning of class, somebody had asked, should I study the exercise problems? Should I study these sorts of problems? Now, and I want you to be honest with yourselves. How many of you meta guessed that D was the right answer because you saw the 4P, right? And if you didn't, phenomenal. But if you did, then you still need to make sure that you can derive this equation without being able to meta guess like that. Because if I gave you this sort of question on a test, right, you're not going to have multiple choice where you can do that sort of process of elimination thing, right? So you still need to make sure that you can actually get this answer the real way. Okay, so we invest a principal P at the beginning of each week. So principal P at the beginning of the week. And we're just going to assume, for the sake of simplicity, there's always 4 weeks in a month, right? Okay, so what I want to do, let's set up, kind of again, a little bit of timeline. 2, 3, 4. This is going to be my month. It's got 4 weeks inside of it. 1, 2, 3, 4. 1, 2, 3, 4, like that, and so on and so forth. And again, we know that we make periods P at the beginning, and then we do interest at the end, right? P, 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 R, P, 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 R. Okay. So let's just try a couple. So if you were one of those people who did manage to get the right answer because you meted it, let's make sure that we can go through this and figure out what the correct answer would be. So after the first month, this is the first month right here, right? This is the first month. So after the first month, how much money is in the account? Okay, and note that we're not going to use this payment. This payment hasn't happened yet. This payment is at the beginning of the next month. Okay, so that payment is not included. At the end of the first month, how much money is in the account? Okay, 4P, but do I get the interest? Right? Okay, we're kind of split. When do I compound? So you compound at the end of the month. And so if I'm asking for you after the first month, so after the first month is done, we did pick up that compounding period, right? So it's going to be, right, exactly. It's 4P times 1 plus R, right? Because you compound at the end of the month, and I asked you, what is it after the first month, right? So we do hit that compounding period. Is everyone okay with that? Does that make sense? That's okay? Okay, now after the second month, so we're going to take that 4P times 1 plus R, and it's not going to pick up any extra P's. And I'm just going to move it forward to the next compounding period. So it's going to be 4p times 1 plus r squared. And then I have another 4p's in here that are going to pick up interest like this. Does that make sense? Everyone's okay? If you're not okay with that, you should say something so I can go into it in a little bit more detail. That's okay? Okay, so you're saying no. So, okay, let me dive into this a little bit more. Okay, so basically, let's ignore this payment for a second. Okay, let's ignore this. Let's ignore that. Okay, so now what I'm going to do is I want to look at all the new principals that I invest. Okay, so there's a principal P here, there's a P here, there's a P here, and there's a P here, right? And I'm going to do exactly the same thing in this month. Is I'm gonna take this, and if I do exactly the same thing that I did at the beginning of the previous month, I get exactly the same amount of money, right? Because if you did each month by itself, they would all look the same, right? Because each month is exactly the same. I don't do anything different one month from the next. So if I look at each month individually, it all looks the same. Okay. So, but I also now, I do have this term and I can't ignore it, right? So this was the amount of money that I had right here, right? That was that amount of money right there. So what I'm going to do, I don't think I made life better with that. 4p times 1 plus r. So now you're confused why it's 4p in the first month? Okay, sure. So that was a private message, everyone. Why is it 4p? Here's a p, here's a p, here's a p, here's a p. So there's 4 p's there. And because there's no compounding interest between these events, so the question is, why is it 4p? There's no compounding interest between these events, which means that they all just add up to each other and then they hit the interest, right? So imagine that I actually put $100 into my bank account, no interest, no fees, no anything like that. The next week I put $100 in, so now there's 200. The next week I put $100 in, there's 300. The next week I put 100 in, there's 400. And then boom, hits an interest payment, right? So now that full 4p got the interest on it, no problem. Okay, so Sylvia, this 4p, which happened here, I also have to push it forward in time, and it's going to pick up this compounding period here. So I'm going to get another 1 plus r, right? I took that 4p, the blue 4p's in the first month, and now I'm just going to treat them as big as a full group, and I'm going to move them forward in time. And then I hit that compounding period at the end of the second month. So it's going to pick up another 1 plus r, right? So that gives me 1 plus r squared like that. Does that make sense? Okay. Had to guess. So either you can repeat that process. Did I freeze again? What's going on? Can you hear me?
Yeah, we can hear you.
Okay, so can you see me?
I can see you as well.
Okay, because on my screen, everything is frozen. All right, so I'm going to continue as if nothing is broken, even though Zoom is like clearly, yeah, something is wrong here. Okay, so after the third month,
Tyler disappeared again. Let's give him just a few seconds to just restart. Probably be here back again. There's writing, but there's no voice. That's great. Let me message Tyler here. I messaged him like privately, like not on Zoom. Don't worry. I messaged him privately, but I just don't know if he's checking his messages right now. Okay, this is Give me a second. Let me try working this out. Unbelievable. Yeah, no. So good. You see my name down there at the bottom. You could tell I'm messaging him. Okay. You see, guys, I'm famous. My name is down there at the bottom right corner. Yeah, no, it is that. I'm not sure why there's a lot of technical difficulties today, but even in lectures in the morning, there were some technical difficulties as well. I'm not sure why. Give him your gratitude. It seems frozen. Thing is, now you guys can see my message when I Slack him, so I can't even actually say anything. I have to be very nice to you guys here. I mean, I could start the poll, but he's gonna have to repeat that previous question. But I could start the poll for this question here. I actually no, I don't think I can. Yes, the polls. I realize I stop sharing. Oh, I can relaunch the poll. Okay. Okay. So meanwhile, while Tyler fixes his last solution, or like kind of pulls it up again. Oh, I think he's back.
Yes, but we'll see for how long. Did you launch the poll?
I did, yes.
Sweet, beautiful. You can keep it up.
The one problem is, Tyler, for your last question, the last like maybe like 5 minutes of your solution, or like a few minutes of your solution, you were writing stuff, but like we couldn't hear you or see anything you were saying.
Okay.
So a lot of them missed the last part of the solution.
Okay, so nobody could hear or see anything?
Yes, based on the chat, I can tell you nobody could hear.
But you could somehow?
No, I could not either.
Oh, okay.
At first I did, but after you started, like it was going for 10 seconds, and then it just cut completely after that.
Okay. Oh, you could see yeah. So you could see the writing, but you couldn't hear me.
Yes, exactly.
Okay. Yeah. So my computer, everyone did. Yeah, thanks. I have Zoom is just making me so angry, right? This is the second time that it's like crashed in no amount of time. So yeah, I'll go back and I'll kind of cover that again quickly. Let's do this question first, which is just a relatively quick adaptation, right? Because it's just saying, I guess it's not. This is actually right. So we'll do this question first, and then I'll go back and I'll try and explain that, and hopefully we don't have any more stupid little technical difficulties. So I know that some of my colleagues were having this exact issue earlier in the year. And it was supposed to be fixed with a Zoom upgrade, but I'm pretty sure I have the newest version of Zoom. So I am very irritated with this. Very irritated.
I'm not sure why that's happening as well. Usually the one thing that was messing it up was the transcripts. And now that transcripts are not running, I don't see why it's just crashing regularly.
Yeah, exactly. Yeah, the transcripts were super messing it up, and now now I'm just crashing. But apparently those people, some people were having issues without the transcripts even, and it almost looks like this is happening. But it's weird because, I've already, assume every month has at least 28 days. So this one, Anaga it doesn't matter if you have 30 or 31 or 28 days in a month, because you know that every month has at least 28 days in it. So in this way, it's right. Like, that last period happens every single time. Yeah. Okay. Where are we? Right, we're on that question. Yeah. So, and then, like I said, I'll go back and I'll explain it. And oh man, just Zoom Making me so angry. Making me so angry. Okay, hold on. I'll be right back.
I mean, while Tyler is gone, you guys should still try to look into the question and solve it right here. We currently have like around 34% participation. So we still have a few minutes nevertheless for you guys to work on it, but just try breaking down the logic here slowly and try solving it.
Yeah, there's a sense in which it's the dual of the previous question, right? That like the previous question had more payments than periods, and then this one has more periods than payments, right? So if you do the same sort of thing, you'll see it works out the same way. But now you have to actually finish it, right? You can't just write down the sum, you actually have to plug it into your formula. But I guess I say it's dual to the last one, but then nobody heard me explain the last one, so maybe that's not a fair, right? Maybe that's not a fair thing to say.
Okay.
So yeah, I had, I've lectured a bunch today already, and the Zoom meetings were totally fine. I wonder if it's a size thing. I wonder if it's so many of you. You all just, you love coming to lecture so much that there's so many of you that Zoom is breaking for some reason. Could be. Someone upstairs doesn't like me, right? But okay, so you remember last week, I warned you all that I was having laptop issues. Maybe this is just me. Maybe I'm just cursed, right? It's not our lecture, it's just I'm cursed. So I was having laptop issues, and you can see that laptop behind me, right? That's the laptop. So I took it into the shop and got it looked at, and I went to the guy and I was like, hey, listen, either there's a fan issue or it's the motherboards. So I have him look at it, and I go back the next day, and he's like, yeah, it's either the fan's broken or the motherboard. I said, thanks, man. I already knew that. That's what I told you when I came in. And so he charged me like $100, and I walked out, and I said, yeah, I'm never going back there again. But then I decided like I needed to, right? And like it still works. It works fine, but it does just do these spontaneous shutdowns, which drives me insane. So I went out and had to buy a new computer, which is why you may have noticed I think you all have a different perspective of me, right? You're kind of seeing me before you were actually like this to me, and you were looking at me like this. And so now you're looking at me like this. Right, so this is a new computer. So I had to spend like a good chunk of the weekend getting it all configured and everything. And that, again, Zoom actually worked, I think, better on that computer than it seems to be working on this one. I'll figure it out though. Just, you got to give me a second, but we'll figure it out. Yeah, I mean, that computer, I love that thing. It's a beast, and it runs so well. I know. Well, you know what? But it told me something else, Curdy, which is like that the problem is not one that's obviously and easily solved, right? So I either need to swap out the fans, and he was going to charge me $200 to do that. I said, no, man, I can buy the fans for like $50. I can swap them out myself. I don't need you to do that. Or it's a motherboard problem, in which case I'm just going to toast the whole thing, because it'd be like $1,200 to replace the motherboard. So, right, I need a new computer, and I'll take that into my office, and that's what I'll use there when we go back to in person. Okay, so we're at about 7 minutes here. I'm going to close this down in about 15, 20 seconds. So everyone get your last guesses in. Yeah, the guy kept telling me, he's like, yeah, man, when I tried diagnosing your computer, it wouldn't even boot into Windows. And I was like, well, yeah, that's a big red flag for me, man, because Windows is not installed on that computer. So yeah, there's obviously you couldn't boot into Windows. At some point too, he's like, okay, listen, can you give me your password? Because I, not to steal anything, but like, just let me so I can get into your computer and run any diagnostics. I said, sure, but it won't do you any good because like, there's just no way you'll be able to use my system, right? It's tailored to me. You're not going to be able to use it. So, I mean, I probably didn't make it easy for the guy, but it is what it is. Okay. Awesome. It's great that I can end Aziz's poll, but anyway, so here it is. 50% of you said C. C is the right answer. Like, phenomenal, everyone. So, I mean, there's still a couple of you that are probably still trying to figure it out. Maybe you made a small error here or there, but like, this is a hard question. And okay, well, if it was meta, it might be a different story. We still need to be able to get the right answer legitimately, right? Without doing the meta. But no, that's still great. It's a hard question. 50% of you are there. It's kind of our first lecture on the annuities. So that's great. Like I'm actually quite happy with that number. So let's go through this. Let's see what it is. And then somebody make sure that I go back and redo the last question, right? And just kind of walk you through it because again, nobody kind of heard my explanation here. Okay. So we're going to finish this question. I'll go back and do that one. So this is actually question 3. Wow, we only got to 3 questions today, but that's okay. They were hard questions, right? We worked hard for these. So here's question 3. So we're told principal P at the beginning of the month. So this is at the beginning of the month. And then we have interest R on the 14th and 28th. Right. And as I mentioned, the reason why we said 14th and 28th is because we wanted to make sure that you had 2 compounding periods every single month, and you didn't have to worry about how many days there were in the month. Is it February with only 28 or sometimes 29 or, 30 or 31 days? We didn't want to have to worry about that. Right. So that's why we said 14th and 28th, just to make our lives a little bit easier. And again, what I think that we're going to want to do is we're going to want to set up always, we're going to set up a timeline, right? And so I'm going to let these be the months. All right, so that's a month. Okay, and then what did we say? So P at the beginning of the month, like this, like so. And then we've got our interest rates on the 14th and the 28th, right? And it doesn't need to be exact. We just need to know that there are 2 of these things inside of every single month, right? We're not worried about it. We just need to know that there's 2. Okay, so I'm going to say, what do we have at the end of the first month? Okay, so let's look at the end of the first month. So at the end of the first month, how much money do we have? Okay, so we're kind of stopping before this payment P, this last payment does. Curdy, exactly, 100%. There you go. P times 1 plus R squared. Is everyone okay with that? Right, because you take this payment P, you push it forward. You had 2 compounding periods, so it's P times 1 plus R squared. Perfect, right? Exactly that. Okay, now at the end of the second month, so this payment P again gets pushed forward, or the exponent of the first variable will double the number of the month. Right, exactly, Ahmed. Yeah, exactly. And Curdy, yeah, nailing it, right? You're on fire. So 1 plus R to the power of 4. So that's this payment, right? That's this payment. But because I push it now through another 2 compounding periods, I pick up 1 plus R and another power of 2, right? And then I do the new payment from this month, and that's going to give me P times 1 plus R squared. And let's do one more month. I think 3 is usually pretty good to give us an idea of what the pattern is. I mean, if you've got the pattern from here, phenomenal. If you don't need it, I like to do 3 just to make our lives a little bit easier. What is it going to be? Absolutely. Yeah. And we know that equals is a plus sign, but exactly everything here picks up another 1 plus R squared. So all the powers are going to go up by 2. And then I pull this thing down, and that's another P times 1 plus R squared, right? So I like to then just say, okay, now I'm going to generalize it. And again, if you can go straight to sigma notation at this point, phenomenal, right? If you can do that, go straight there. So the end of the nth month, that's my N. the nth month, right? We're looking for a pattern here. And who said it? Ahmed, you said it, right? Like at the end of the third month, the highest power just seems to be double that. And then I don't end in a P, I end in a 1 plus R squared. So I can kind of just be like, all right, that's going to be 1 plus R 2N plus ... plus P times 1 plus R squared like that. And then if I want to sigma notation this, it would be like this, P times 1 plus R to the 2K like so. Okay, so does that make sense? Does everyone see how we set that up? All right, and that's great. Like if y is k equal to 1, okay, and I got another one of that from another thing. So look at this one, k, so let's say k was equal to 0, okay? If k, yeah, okay, let me do the sigma notation because I know that some people still like really hate sigma notation. Okay, so what is the common term here? When I jump from like 1 plus R squared to 1 plus R to the 4 to 1 plus R to the 6, what is the common ratio here? What is the term that's increasing? Okay, yeah, there's a couple things here. So it's 1 plus R squared, right? Now, Namir, you're right. Be careful though, because the P isn't included, because if I multiplied by P each time, I'd have like P squared 1 plus R to the 4, P cubed 1 plus R to the 6, right? So the P actually isn't part of it, right? So be careful, everyone. When I ask what is the common ratio, I mean, what do I multiply the first term by to get the second term, and the second term by to get the third term, right? So it's 1 plus R squared. So Jeremiah, you're right, but don't forget your brackets. Otherwise, that would just be like R squared, right? So the common ratio here is 1 plus R squared. And, I can pull that P. Maybe that's what you guys were thinking about when I asked, what's the common ratio? Maybe you were thinking like, oh, I'm going to put the P in there, which is fine. But usually common ratio just means what do you multiply the first term by to get the next one, right? And we could take that P out if we really wanted to. Okay, so it's going to be 1 plus R squared. Maybe let me write it like this. So it's going to be 1 plus R squared to the power of K. Now, and somebody asked, how do I know it's N and how do I know it starts at 1? What value of K corresponds to this thing right here, right? And actually, maybe let me combine these. That's going to be 2K like that. What value of K gives me 2? 1. That, Kirti, is why it starts at 1. Does that make sense? Right? Like I set up my sum first, and then I said, right, like what number do I have to start at? Okay, and now same thing. I don't remember who asked it. What number of K gives me 2N? Right? What K do I plug into? So what value of K do I use to get 2N? Right, use N. Does that make sense? Did a bunch of sigma notation ahas just go off? Because if it did, like that's phenomenal. Like I would love that. But does everyone understand now why the sum started at 1 and why it finished at N, right? So can I repeat about the N? Sure. Okay, so the exponent here is 2K, right? And we know it ends at whatever, oh no, why did I delete my sigma? Whatever number I put here, that's going to be the last thing that I plug in for K, right? So whatever number is where those question marks are, that's the last thing I'm going to plug into K. And this is the last thing in the sum, this 2N. So the question is, what value of K must I plug into 2K to turn it into 2N, right? And the answer for that is N. So same sort of thing. What if this wasn't a 2N? What if this was a 24? What would my N have been? What is the value of K such that 2K is equal to 30? Exactly, right? It's 12. If I said what value of K makes 2K equal to 24, then we would have put a 12 here, right? So if I put, let's do another one. If I put 58 there, what would I have used? Yeah, exactly. This is sort of like a dyslexic thing. Yeah, 29, exactly. So if I put a 2N here, then this answer is N. And yeah, Sylvia, exactly, 58 divided by 2. So everyone makes sense with the sigma notation? Okay, that's good. Did anyone like was confused about sigma notation before and now understands it a little bit better? Because I think that would be super cool. Yeah, okay, cool, right? So yeah. So sometimes you just have to like it helps as well that you've all been thinking about sigma notation for a bit, and then we had this kind of cool clarifying example that you've thought about it for a bit now, and then you had some little bit of enlightenment, right? Yeah, absolutely. Practice a little bit more. Okay, so now we also know we have this formula because we're not done the question yet, right? The question didn't have any sigma notations in it. So we know from our time back in week number 1 that this is equal to r times 1 minus r to the n divided by 1 minus r, or maybe let me use s's here just so we don't confuse what the s's and r's. Okay, so what is s in this equation? What is s? What am I going to set s be equal to? Yeah, see Aziz. Okay, hold on. What's the, right? Remember here, this is the common ratio. That's what this s is. It's the, right, Namir has, this is 1 plus r squared. Let's make sure that why we understand that, right? It's the term, maybe again, let me write this in a slightly different way. Let me write that as 1 plus r squared. Oops, sorry, that 1 plus r squared to the power of k, right? The thing inside of the square brackets is my s, right? Does that make sense? Okay, so now I'm going to plug, I'm going to use my formula and I'm going to plug in s equals 1 plus r squared into it. So if I evaluate that, I'm going to get p times s times 1 minus s to the power of n divided by 1 minus s, like that. And that was answer C. S is, yeah, exactly. It's just an arbitrary variable, Jeremiah. And for the purposes of this equation, it's just a placeholder, right? And the reason I didn't use R, normally our formula is R, but we've already used R for something else. So I didn't want people to get confused between the two values. And so I just called it something else, right? Just temporarily so that we could plug it in and didn't have to worry about getting the R's confused. Yeah, Ruben, does that make sense? You get it? It's all nice. Can we move to the P to the other side? Yeah, absolutely. In the sigma, 100%. Yeah, we can just pull that P out there like that. Is there a sheet of all the formulas or do we have to make one ourselves? I mean, Ethan, I recommend making one yourself, but I mean, the test is open book. You can, you can reference your notes all you want. So you can definitely make a sheet if you want, or just look into the book if you forget. I got a direct message which says if k is equal to 0, then you cannot just use the formula. No, you can, because we have a formula for k is equal to 0 as well, right? So we know that the sum from k equals 0 to n of r s to the k is 1 minus s to the n plus 1 divided by 1 minus s. So in this case, you could use that formula as well, right? Yeah. Okay. Yeah, exactly. In this case, s is the common ratio. Yeah. And actually what you could do is if you want to figure out the common ratio, if you actually have the sum like this, okay, so look at this term, okay. If you want to figure out the common ratio, take one term and divide it by the previous term. So if I take, for example, p times 1 plus r to the 4 and divide that by p times 1 plus r squared, the answer is just 1 plus r squared, right? That's how you actually figure out the common ratio, is you divide one term by the previous term. And it doesn't matter which term you used, try it. If you had used the 1 plus r to the 6 and then divided it by p times 1 plus r to the 4, you would have gotten exactly the same thing, right? So that tells you what the common ratio is, okay? All right, now, of course, for those of you who have to run, go run. I'm going to keep recording, and I'm going to go back and talk about, again, what I did in that question where I froze and nobody could hear or see me. Okay, so if you have to run, it'll be in the recording and you can check it out after. For the test, can we log out and come back to it? I mean, yeah, that doesn't even make sense because there's no logging in. I'm going to post a PDF and you're going to look at the PDF and you're good to go. Can I see the first question, like the actual question of the first question? Yeah, okay, so I'll throw it up here if you can like maybe take a screenshot or something of it because I want to go back to that second question. It's going to be like 3 questions or something. But who knows? Each question could have multiple parts. And so we don't know exactly, right? Like knowing the number of questions doesn't necessarily tell you much about the test. Okay, you got, okay, perfect. All right, so let me go back and let me cover this one again because of our technical difficulty. So where did we get to? I'm trying to remember where we left off. Does anyone, I think it was here, right? Is that where I died? Was right when we were talking about the 3rd month? Okay, 3rd month. Okay, so I'm actually just gonna erase this because I might as well just redo it. It doesn't matter. All right, everything's erased. So is everyone, let's take a second and recall what it is that we were doing, because I don't just want to jump back into it because everyone will be super confused, okay? So remember, in this scenario, we're compounding at the beginning of each week and we're compounding at the end of each month. And we're assuming that every month has exactly 4 weeks inside of it. And we figured out how much money we had after the 1st month, and then we figured out how much money we had at the end of the 2nd month, right? Isn't the exponent to be in the first set? Like, maybe, it depends what you mean. Like, I kind of wrote these backwards. Let me maybe write it out again. Right? So I pick up another R like that, and then I have my next 4p times 1 plus R like that. Yeah, exactly. But those, I had just written it the other way around, right? Like I didn't write down anything different. I just had the yellow thing first, which is kind of weird. But yeah, you're right. Absolutely. The blue thing picks up another 1 plus R. So it has the 1 plus R squared. And then I have a new 4p 1 plus R. So is everyone okay up to this point? If you have any questions, let me know. I'm happy to go over it again. Otherwise, I'll go and I'll do the 3rd month again. Okay, so is everyone all right with that? All good? Okay. So now in the 3rd month, so after 3 months, so again, everything that I've drawn, or like this amount after the 2nd month, everything here is going to pick up another. Well, no, that's great then, Ken, right? Like as you do harder and harder questions, the hope is that the other questions become easier, right? So everything here at the end of the 2nd month is going to pick up another 1 plus R squared, right? So that will give us now 4p times 1 plus R cubed plus 4p 1 plus R squared. And then all this stuff is going to come down, right? And I'm going to get 4p times 1 plus R. Okay, is everyone good with that? That makes sense? Like I said, right, I like to go to 3 months and from that try and figure out what the pattern is, right? Right, exactly. So the common ratio is 1 plus R, exactly. That's awesome, right? Like you're using the things that you just learned and applying them to this question. And that's exactly what I want to see. So let's do it first of all. So now after n months, oops, sorry. So after n months, okay, I'm going to try and guess my pattern again. So after n months, and again, I noticed that the 3 here seems to be the highest. So probably the highest term will be 1 plus R to the n, right? And then we're going to go dot, dot, dot. And they always seem to end in 4p 1 plus R, so that's good. And then as Curdy was mentioning, okay, so our common term, maybe let me pull, right, we have that 4p, and the common ratio is 1 plus R. So we're going to take that to the k. Now again, what value of k is this one, right? So that's really a 1 there. What is the sum going to start at? Exactly, k equals 1. And what value of k will give me that exponent? N, perfect, right? And there we go. And this is like, that's the end of the question, right? That's what the question wanted. Now, if you wanted to, you could do the same thing we did in that last question and actually go ahead and plug this into the formula for a finite geometric series and you would get an answer. That's now the question just wanted us to stop here, right? So we could stop here. But you can imagine it would be very reasonable as a test question to ask you to take that extra step and plug that into the formula that we have, right? K equals is always what you plug into K to get that value. Absolutely, exactly, right? Like, I haven't written it down, but there's also, a 4p 1 plus R squared here and a 4p times 1 plus R to the 1. And so same sort of thing. Notice that after K equals 1, what would you do? You'd use K equals 2, right? And then after K equals 2, there's k equals 3, and I didn't write that term down, but it's in the ... right? It's part of that thing that I omitted. And that's what's happening is every time you set k equals 1, and then you plug it in. You set k equals 2, and you plug it in, and so on and so forth. Okay, no, that's a good question. Oh, you're right. So I actually did a harder question because the question, as originally stated, actually only says to do it for a year. So the nth month is actually the 12th month, right? And so you'd put 12 everywhere. But if you can do it for general n, then you can do it for any number of months, right? Like there was nothing special about 12 here. If I'd asked you, like you can do it now for general n. So if I said after 3 years, you would let n be 36, right? Because that would be the number of months that passed. So the fact that we only did it for a year there, you're absolutely right. The final answer should have that being 12, but I don't think it's that much extra work to actually do it for a general n. Yeah. Yeah, exactly. So the answer in the thing here, let me actually pull up the question for you so you can see it. It's this one, I think, right? Yeah. And you can see here, the correct answer is D, and it does actually have the 12 in there. But you can imagine I'd said after like n months, and then the answer would have had the n in it instead, right? So yeah, that's exactly how you do it, right? So this is great to me because we did question 3. We came back to question 2, and suddenly everybody knew how to do it, and that's phenomenal to me, right? Again, everyone's kind of like learning, and that's exactly what I want to see. Yeah, and exactly, Sigma makes more sense because like now you're kind of seeing it in action, and again, you've had some experience with it, and things will fall into place a little bit better. When do we get to geometric financial things, Jeremiah? What do you mean by geometric financial things? Because that sounds like a lot of fun, but I'm not certain what it means. And then what do I do with the S in question 3? Is there an S in? S is just the placeholder. So this S here is just the formula, right? So I'm looking at this equation right here. This S is just the formula. So S is just a placeholder there. So I was just going to let S be, I was trying to figure out in this equation, what should I set S to be? And I chose 1 plus R squared. And then I was going to plug it into my sigma notation. Yeah, exactly. It's the formula. Yeah. So Rafid, I don't understand what you're asking. What do you mean? Why did we have to do this? Can we do another one like this with sigma or something? Sure, I can set something up like that. So should we have the answer in sigma form in the assignment? You don't have to, but if you want to, great, as like good practice, you absolutely can. And Rafid, I just assume that you're typing out what your question was. Yeah, okay, here, listen. I'll make one up here in a second. Okay, yeah. Like I'm more than happy to make up questions like this. And especially if you guys are like excited because you get it and it makes sense, like I'm more than happy to do something like that. Okay. So, all right, let's do something nuts. Let's do something more like, do you want me to make it more difficult or do you just want something about the same difficulty? More difficult? Okay, so let's do the following. Okay, so I'm going to call this like bonus question, right? Because it's not in the polls. So let's do something like, okay, let's see. So let's say we invest P dollars every Sunday. And this one's probably similar to what I did in the video, but that's because, I can only be so creative. But let's invest P dollars on Sunday, and then let's say compounding at R, and we compound at R on, let's say Monday. Let's say S on Wednesday. And then let's say R again on Friday. Okay. What is, how much money do you have after n weeks? Or what's the future value of the account? What's the value of the account after n weeks? Okay, now I want you all, I know that some of you probably just want me to do it, but since you all seem like excited that things are making sense, I really want you to try this one on your own. Okay, so I'm going to give you 5 minutes again and throw questions in the chat. I'll be happy to answer them. But again, now that you're like in the mode and like stuff's making sense and you're on fire, like I want you to, I want to give you a chance to solve this. I don't just want to deprive you of that opportunity. Okay, so let's take like 5-6 minutes or something and see if we can figure this one out. And again, throw things in the chat if you have any questions. Yeah, new week. Yeah, exactly. Oh, that's actually a great question. Yeah, so let's assume that the week starts on Sunday. Yeah, so that we're going to invest at the beginning of the week. Yeah, good question. Okay. If you manage to solve it and you've pre-typed in the chat, you can go ahead and now hit enter. Like, I don't know if anyone's done that or they're still trying to figure out how to write out sigma notation. But I think a couple of people think they got it, which is awesome. And then, yeah, we'll do it. No, nobody typed it. It's always so hard to tell because I have no indication whether anyone is typing. So whether it's not like if people are typing or not, for sure, it is a lot to type. That's fair. Yeah, what I'm saying is like, I wish something came up on my screen to say who was busy typing at the time, because sometimes I can't just tell if it's total silence or if it's just because there's so much to type that people haven't had an opportunity to like hit enter yet, if you know what I mean. And so, yeah, I have no way of determining that, but. All right, so I'm going to fill my tea, and when the tea is filled, if there are no, I'm going to take it out. So if you want to get that answer, and you got to do it before the tea is hot. All right, Ariana, that looks pretty good. I like it. Typing out the answer is confusing. Sure, yeah. And so, Ariana, here's the cool thing. If you go into Piazza, right, where we talk about LaTeX, if you instead of writing sigma, write sum, your thing will compile in math perfectly. Right? So if you did sum instead of sigma, it would work out exactly right. Okay. So yeah, it's totally cool. Okay, so let's take it up. I think a lot of you have the right answer or are like giving me what is in front of the sigma because you don't know how to write the sigma down, and that's totally fine. Like you got the right thing. So let's go through it now. And again, I'm gonna always timeline, right? I think we've seen how useful timelines are now. So we always just want to do a timeline. And if you don't want to mark off like Tuesday and Thursday and Saturday, I don't think you have to, right? Because I don't think it really makes that big of a difference. The only thing we need to know is the start of the week has a payment P, right? And then we have R, and then we have S, and then we have another R, right? And let me just fill in the rest of those. And I'm going to put the S's in, but I just don't want to keep jumping between colors like this. Okay. Yeah, no, phenomenal. And this is the thing, like math is actually, you get a little bit of a high when you solve problems, right? It's just like a small little endorphin hit because like you feel great afterwards because you took something that you had no idea how to do, and then all of a sudden you can do it, and it feels really good. And that's how math is supposed to feel, right? And I want you to all to think about this. So Jeremiah, if you have this feeling now, like think about, do you think that this sort of stuff is harder and more abstract than what you learned in high school? Because I think maybe it's not harder, I don't know, but it's sure as hell more abstract, right? Like the stuff that you're doing now, I think is more complicated because look at it, we're using P's, we're using R's, we're using S's. There's no numbers here, right? I didn't say P is $100 and R is 5% and S, right? You guys are doing way more abstract stuff. So I've given you more abstract stuff, and what are you doing? You're kicking its ass. And like, think about that. Coming out of high school, did you ever think you could do that? Because I think, some people were like, no, like, I'm not very good at math. And then I give you abstract stuff and you're kicking its butt. So like, you should have a lot of like, you should feel really good about that, right? Because that's a great accomplishment. That's a cool thing. Okay, so here's our setup, right? So at least, Ken, like you're saying, or sorry, Louise, as you were saying, like, at least we know the setup is correct. And again, I'm just going to go 1 week at a time, right? Don't try and do the whole thing at once. That's crazy. Let's just do 1 week at a time. Let's take this P and we're going to push it forward. So after the first month, or sorry, after the first week, so 1 week, and a bunch of you already wrote this in the chat, right? We're going to pick up 1 plus R squared times 1 plus S like that, right? Because we have 2 compounding events at R and 1 compounding event at S. And then after 2 weeks, right? So this payment is again going to go through and it's going to, pick up the 1 plus R squared, 1 plus S again. So it's going to become 1 plus R to the 4, 1 plus S squared. And then we do it again and throw it in here. And by the way, everyone, if you practice this enough, you will eventually get to the point where you don't have to do this, right? Monday and Friday, just ignore it, means 2R. Yeah, it's R squared, right? Because remember, you pick up, so what it's really going to be when you do a week, right? And you do R, and S, right? So when you get to here, you get a P times 1 plus R. When you push forward, you'll pick up a 1 plus S. And then when you push forward, you get a 1 plus R again. And so you get the 1 plus R squared, right? Does that make sense? All right. So, be careful about that, because I know that is a fairly common mistake, but you're going to get 1 plus R all squared. Okay. But yeah, once you all practice this enough, you will be able to go straight to sigma, right? Like that's advanced. I don't in any way think you should all be able to do that. But if you practice enough, that is actually possible. Some of you will be able to go straight to sigma notation. Okay. And then if I do it one more time again, just to get my pattern down, 1 plus S squared, cubed, and then 1 plus R to the 4, 1 plus S squared, times 1 plus R squared, 1 plus S. Okay. Yep. And Curdy, exactly. That is the common ratio, right? And you notice that the common ratio it really ends up being the number of compounding periods in between each of the deposits, right? Like that's exactly what that is. What 1 plus R squared, 1 plus S is the compounding interest term between each period, right? And that's what I'm saying. Like if you practice this enough, you can just see that that's going to be the common ratio. And then given the description of a problem, you'll be able to guess exactly what it is. Okay, so after n months, let's just finish this one off. The pattern seems to be, like I look at 3. Okay, so it's double, right? It's double whatever the week is in the power of R, and then it's just whatever the week is in the power of S, right? So that's going to be 1 plus R to the 2n, 1 plus S to the n, plus dot, dot, dot. P 1 plus R squared, 1 plus S, like so. Okay. And then, as Curtis said, common ratio is, right, this, again, let me take the P out just so that we're not confusing it with the common ratio, is going to be 1 plus R squared, 1 plus S. So I'm going to put, or 2R rather. What am I doing? 2K, 1 plus S to the K, like that. What's the first value of K? What should I set K to be to get this one? 1, exactly. What's the final value of K in order to get that one? N, beautiful. Okay. Okay, this is, Sylvia, let's be careful. So the 2 is already accounted for here, right? So when I plug N into the 2 there, I get the 2N. And when I plug, do you see? Yeah, okay, yeah. So just be careful of that one, right? Because like, obviously, if you got to this point and you made that mistake, you're getting most of the marks, right? If you wrote down 2N instead of N, you'd get almost everything. But that's a place where you'd be really upset with yourself, I think, when you got your test back and you'd be like, oh man, I can't believe I made that mistake, right? Like you'd be kicking yourself, right? So just be careful about that one. Why is it K equals 1 again? Didn't you answer? Okay. I thought you answered 1, but maybe not. Okay, so here we have 2 and we have a 1. Okay, let's look at 1 plus R to the 2K, and let's look at 1 plus R squared, and then 1 plus S to the K, 1 plus S to the 1. And again, the question is, what value of K makes this happen, right? Like if I look at the yellow boxes and the blue boxes, the same K has to work in both cases. What value of K am I going to plug into the sum? Right, okay, yeah, you remember that. So it's clear it's 1 now? Yeah, that's good. And sigma, yeah, no problem. I'm happy to reaffirm that. Sigma K equals 1 is still, okay, and the N is your top part, right, N? Like it's, yeah, okay, yeah. And I'm sorry, I'm certain I've gotten your name wrong. I keep meaning to ask you how to pronounce that. Can you come on mic if you feel comfortable and tell me how to pronounce your name?
Yeah, sorry. It's Ain.
Ain? Okay, good. Because you comment enough and I keep wanting to say, like, call on you, but I'm so afraid to screw up your name. So thank you. Now I know. Did I tell you all about the story about my one student who I had for like 3 courses and I kept saying her name wrong? Until finally she was like, no, that's not how you say my name. And we had to sit down for like 20 minutes. So I practiced it. I'll show you her name in a second. And you can tell me how you think to pronounce it. I changed the P 1 plus R squared 1 plus S to P of S just to be shorter and easier. Jeremiah, that's fine. But what I would say is just be a little bit careful about reusing S there, because now S means something for us, right? It actually is an interest rate. So like, I think what you're saying is you rename the common ratio a new thing. And you just want to be a little bit careful about that, right? So maybe use a capital S or something just so that we're not reusing the same letters. Okay, and so Curdy, this is the final answer if we just want to stop at sigma notation, okay? Yeah, and I'll tell you all about the name in a second. Let me just make sure I get all the questions about that. If there are 3 R's in a week, would we expect the exponent to be 3K? Absolutely. And yeah, let me show you all this, a really cool, so is it still right with R, S, and T? So with R, S, and T, you would get this. So that's what you would get. Does that make sense? Okay. And the cool thing about this is that notice that if I set R to be equal to T, then we get the same answer that we just found. Right? And then, and Theodora, you said if there were 3 R's, would it be 1 plus R to the 3K? Notice that if S was equal to R and T was equal to R, then we would get exactly what you hypothesized, which would be 1 plus R to the power of 3K, right? So this is like, in some sense, the most general. And then when you want to, specialize it for special cases when T is equal to R or S is equal to R, then it's still true, right? That still ends up being okay, right? What would be a scenario where there would be a coefficient in front of the P? So if somehow I deposited both on Sunday and the beginning of Monday before the first compounding interest payment of R, then I'd have a 2P in front of the P. Does that make sense? So basically what I want is multiple payments to come in before I even start compounding. And that would do it, right? Pardon, give me a second. Let me just try and get through the rest of the questions here. I completely got this question, but in question 3, why and how did we do the steps? Right, so let me, so a person who direct messaged me, I will finish it and I will actually plug this into the formula for a finite geometric series. I'll do that in a second. Is it still the same if we combine it? Yes. Ain, right? Ain, I think I got that right. And yes, if you take all of that to the power of K, that's the same thing as what I wrote down. Those are the same thing. Can we use geometry or geometric series to find the final answer? Yep, Sylvia, I'll do this in a second. Parneet, sure, unmute here.
Hi, sir. So my question is like how we did in this, like our P value remained the same since we were investing the P every month and every week. So like, what if like we are investing P every week, but like our compounding period is changing? Like right now it's like 3 days a week, but like what if it changes to like for the first week it's 3 days and then it changes to like 4 days the next week? So then, will our P value will change too or not?
Everything changes. You probably can't write it as a sum anymore. You'd have to do it like I did here, where after 1 week, after 2 weeks, after 3 weeks. And then because it's changing so often, like if it, let's say it did something nice, like three times a week, 4 times a week, 3 times a week, 4 times a week. So it kind of repeated like this. It would be possible to reconstruct it as a sum, but it's actually going to be 2 sums to make that work. But if it was like random and changed every week, so it was like sometimes 3, then 4, then 2, then 7, then 5, then 6, then there's nothing you could do. And you just have to go through it 1 week at a time and figure out what the formula was.
Okay, so like if we have to then come up with our final answer, so we'll just like do separately and then just come up with the final answer separately?
Yeah.
Okay.
So But this is actually a phenomenal question. So if you really want to test yourself and test if you understand this. So first of all, everyone, I think as far as I'm concerned, if you got this question, you're in a really great place. Okay, like you understand annuities, you understand how to set these things up. You're doing very, very well. Praneet, your question is phenomenal because it adds an extra twist to it. So it makes it just a little bit harder. Mm-hmm. So, let's now, what I want you to do is try this. And then if you don't know what to do, we can talk about it next on Thursday in office hours, or you can throw it on Piazza. Do it where you have some compounding scheme of 3 times a week. And then the next week you do 4 times. Okay. And then 3 times and 4 times, and see if you can write that out.
All right. Yeah, I'll try, and then I can talk to you after that.
Yeah.
Thank you. Thank you so much.
No problem. And if you can get that, then you're 100%, you got this, right? Like there's no question I could give you that would be harder than that.
And if I still have some doubts about this scenario that I'm having, so can I ask you next week again?
100%. Yeah. We can talk about it next week. We can talk about it on Piazza. We can talk about it in office hours. Just bring it up because it's such a great question. I think, yeah, it's a phenomenal thing. Okay. Okay. Let me, Accidentally compounded. I'm just curious, will we ever do a question where it's P that changes? Yeah, that's absolutely possible. Teodora, this is, okay. So Teodora, this is your question. What I want you to do is, let's assume that we have the scheme up here, but it's P at the beginning of the first week, and then capital R at the beginning of the second week, and then capital P at the beginning of the first week, and capital R in the second week, and it repeats like that. And see if you can do that problem. So again, I would never ask you a problem harder than that. That's definitely the apex of how hard a question that I could give you. And I think that's probably on the tough side. But if you can answer that question, then you're in really great shape. And then come back. And if you're not certain, we can talk about it next week. We can talk about it on Piazza. And, again, that's kind of your apex achievement. If you can answer that question, then you're in a really great place. And I want to emphasize, everyone, something else that's happening here. And I know for those of you who are like, can we do this with the geometric series? I'm going to do it in a second. But so many of you are asking these great, phenomenal questions, right? Which is like, what would happen if we did this? Like, what would happen if we just like twist a little thing? Like, how does it change? And I know 100% that your instinct here is to ask me, and that I will be able to provide some sort of guidance. But like, I think many of you will be able to answer this question yourselves. So ask yourself, like, what would happen if I changed the number of compounding periods, or I changed the principal that was being invested, and then see if you can answer it. And then after that, if you get stuck or you want somebody to check your work, throw it on Piazza, come talk to me during office hours. Whatever the case is, pull it up in tutorial. We'll be happy to go over it with you, and we can tell you if your answer is correct. And if you made your own question that was super hard and you answered it correctly, there's nothing better I can do for you. You understand that concept 100%, right? And there's nothing more that I can offer you. So I love these questions. I really do love them. And I never want to discourage you from bringing them to me. But what I also want to encourage you to try to do sometimes is to ask and try to answer your own questions, because that's really the next level, right? That's how you go from beyond just being like, a good student, and how you start to become a phenomenal student. That's that next level. Ask and answer your own questions as well. And of course, I'm happy to help you answer those questions if you get stuck. Okay, so that's kind of like the next level of where that goes. Let me do the geometric series, because I know a lot of people are getting probably a little bit antsy about it. So we're going to put this one to the side. I can come back to it later, but we're going to forget about that one for now. So as we were kind of saying, the common ratio for this question is, I'm going to use capital S here. The common ratio is 1 plus R to the 2 times 1 plus S, right? And now I'm going to plug that into my formula. So that K equals 1 to N of capital S to the K. Again, I'm just trying to use a different letter because we've already used the little s, right? And so I don't want to confuse those two things. So I'm going to use capital S now just to keep those things separate. So we know that this is the formula. So now let's plug everything in. And if I plug everything, I'm going to get P times 1 plus R squared, 1 plus S times 1 minus 1 plus R to the 2 N 1 plus S to the N divided by 1 minus 1 plus R squared, 1 plus S, like that. You don't simplify that any further, right? Like, don't expand the denominator. if you expand out that denominator, it's actually going to look worse than if you just leave it like this. As far as I'm concerned, this is a phenomenal answer. And if you came up with this, then that's 110%. As far as I'm concerned, like I'm just so impressed. If you got to this answer, that's great, right? And you should feel good about yourself. And if you didn't get here, that's fine. But hopefully now we've done enough of these questions that you've got this sort of idea about how to get here. And so this is what you want to work towards, right? Because you don't want to just train to be 100. You want to be trained to be 110, right? You always want to overshoot what you're trying to actually achieve. Both answers absolutely are fine, but keep in mind that it does depend on what you're asked. So on a test, it's perfectly reasonable that I could ask you to stop at sigma, but it is also perfectly reasonable that I could ask you to plug it into a geometric series, right? In which case you might actually have to take that final step. So always practice to do the final step, right? Just in case that you're asked to do it. Yeah. Okay, did I miss any questions? If I missed any questions, please someone yell. Why is it kind of easier now when your formula is in sigma? I'm not certain what you mean. Like, why is it easier to plug things into the geometric series formula when it's in sigma notation? Is that what you're asking, Ain? Like, right. I mean, it's just, I suppose if you practice, it doesn't have to be easier. So if I were to write, 1 plus r squared plus dot, 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 plus r to the 10, you might be able to guess how to just use the formula for this, right? No problem. Yeah, that's great. So you might be able to guess how to use the formula for this, but I kind of need to even write it in sigma notation, right? Like r to the k like that, and then apply the formula. Because for me to apply the formula, right? And again, the formula is, this one starts at 0, right? So the formula is so for me, what I can do is I can clearly say, okay, this n goes here, and this is the common ratio. And if I look at this equation, I have to say, okay, wait a second, am I starting at 0? Am I starting at 1? And then what's the n? Oh, that's the n. And then what's the common ratio? R. Okay, right? Do you know what I mean? Like I personally, if I see a string of sums like this, I have a little bit more trouble picking out what the variables I need to plug into the equation are. If you can do that, that's totally fine. As far as I'm concerned, if you can manage to avoid using sigma notation and you can just go straight from this to the answer, I'm fine with that. Legitimately, I'm 100% like not super upset. That being said, you could have test questions on sigma notation, but as far as doing annuities is concerned, I'm more than happy if you can do this without plugging it into sigma. I use sigma because for me, it's much easier to understand what to do. And the notation is much more compact, especially when you get into more complicated things. Sigma notation is a real lifesaver, right? There are lots of things where if you had to write it out without sigma notation, your life would just be terrible and it would be a real mess, right? So for example, if you want an example of one of these, right? Does anyone know what this thing's called? Can we take a one where R changes every week? I can try to do that, Owen. We'll see what that is. This thing, by the way, is called the binomial theorem. Right, and sigma notation is very valuable for us there. When a question, okay, so Owen, I haven't missed your question, but I think I can answer Parneet's quicker. When a question asks about withdrawal amount, do we use the present value formula future? Can you point me to a particular question that uses those words?
So like I was trying to solve the assignment too, right? Like it asked about the withdrawal question, the second one. So it was asking that what will be a withdrawal amount after June 30th, right? So regarding that question, so do we use the future value formula or the
Oh, I see. Okay. Well, yeah. Okay. So for question 2.1, for example, it says, what's the value of the account when you withdraw it on June 30th? Yeah. So the word withdraw there is not the important thing. The because like it doesn't matter what we do with the account. If we just said, what is the value of the account on June 30th?
Mhm.
Would you want to use a future or a present value? Like assume, sorry.
Like I would think, like I was thinking about it like since yesterday. I was thinking that I would use a future value, like since I know the R and I know like everything about that question.
Mhm.
Like, and I just have to solve it, like what will be the amount at the end. Like I just don't need it. Like, so that was just a doubt that I had.
Well, I mean, another way of looking at it, if you want, is, today is what, January 1st? And I'm asking for you to compute the value of the account on June 30th. That's in the future, right?
Yeah.
And on all the payments are going to happen before June 30th,
Mhm.
or all the compounding. So you're going to push that money forward in time. So that's the future, right? So when you pull money back to the present, that's the present value, and otherwise it's the future value.
And one more question. So
Mhm.
since this question is just like the first part, it's just asking till June 30th, and we already know that we are using R1 till the first part. So that means we are not using the R2, right? Like just
Right.
R1.
Yeah.
And first, and just one more clarification. So since R1 is not given, it's the effective rate that's given, right? So
Right.
we have to solve for R1, right?
Yeah, exactly. You've got to figure out what R1 is.
Thank you.
No problem. We would always need to get the nth form right in order to see what sigma. Okay, so Curdy, yeah, I'm going back a couple of questions. It is possible to get around using sigma notation. I don't know if maybe I didn't have already answered that from before, but it is possible to avoid the sigma notation to do this, but I think actually doing sigma notation is easier in order to figure out what the formula is. So Owen, when you say you want R to change every week, so you want to say something like, oh, we're going to compound it R in week 1, and then S in week 2, and then T in week 3, and it never repeats, or does it eventually repeat? So it never repeats. It is, but then you have to start to get a little bit tricky, right? Like basically, I'm going to call it R1 at the end of the first week, R2 at the end of the second week, R3 at the end of the first week. It is possible, but I also, like, if you thought sigma notation was bad, there's this thing. Which is, instead of adding it, you're going to multiply all the things together. So that's a really interesting question. If you want to write it compactly, you need pi notation, this product notation. It's a cool question, but it's the sort of thing that actually you could be asked, but probably I could only do it for a couple of weeks, and then I'd ask you to write it without sigma notation because it would be too hard to do with sigma notation, right? So it's a really interesting question, and I suggest you try it, right? Try making a question like that, but only do a couple of weeks, because if you try and do it to the nth week, it's going to be very, very hard. But do it for like 3 weeks and see if you can write up the answer, and then bring it to me, and I'll be happy to go over it with you. Right, so give it a shot. Can we do a similar example from assignment question 1B? Sure. Let me think about this. So like 1B is not, okay, no, okay. So here's a similar assignment question to 1B. Let's use this. Okay, I'm going to use this exact problem. Okay. And I think that I can get you to where I want you to be just from this problem. So again, we're going to use this problem, and I'm going to actually give you numbers now. Okay, so I'm going to tell you. So we're going to do P is equal to, I don't know. No, we don't know what P is, right? We're trying to figure out P. So R is, let's say 5%. S is 10%. And we're going to do it for, let's say, N is equal to 10 weeks. And we need to have, let's say, $10,000. All right. So we know after 10 weeks that the value of this account has to be $10,000. Right? Does that make sense? Does everyone see how this is related to 1B? Right? So this is the value, and I know what the future value has to be, right? I've just said the future value has to be $10,000. Well, how do I solve for P? Yeah, I mean, sure. I mean, we divide by the sum, right? So when you answer question 1A, you're going to get an equation like this, right? It's not exactly this, obviously, but it's going to look like this. And you're asked to find the value of P, which makes S equal to 10,000. So solve for P. Does that make sense? And Ariana, I do see your question. Let me just, I want to sort this out before I come to it. Are there any questions about this in concern to like question 1.2? And it's 10 because it's 10 weeks. Exactly. And the question tells you exactly how many, right? The assignment question tells you how many weeks you're going to do. You're going to do it for 15 weeks. So it tells you how long you're investing. It tells you exactly what the percentages are. And at the end of the day, you're going to get some weird thing that maybe you can write a sigma notation, but if you can't, it doesn't matter because you can factor P out of every term and then you can just solve for P, right? And that's how you do that. Okay, so is that enough of a hint on how to do 1B? For this problem, I would probably like you to plug it in and get a number out for the assignment. But like for the most part, you would get most of the marks if you left it here. But I think that the reason why using a calculator is sometimes good is because it can sanity check you, right? So you need it to earn $15,000. If you plug in this number and you get a number more than $15,000, you should be like, that doesn't seem right, right? You're doing it for 15 weeks. So you're making 15 payments. If the number you get is more than $1,000, something's wrong, right? Like if you invest $1,000 15 times, you should definitely end up with more than $15,000 after 15 weeks. So the value of using a calculator here is you can sanity check what your answers are, right? But for 1A, you can't get a common ratio. Curdy, that's right, but that maybe just means that you're not supposed to use a sum, right? You're not supposed to use a sigma notation. You can still solve for P without using a geometric series, right? Because the thing that you're given might not be a geometric series. Does that make sense? Right? Like you can still do it the hard way, which is, like let's say I didn't have a geometric series here, or I didn't know it was a geometric series. I still have P times, let's say after, 2 weeks instead. Right? I can still solve this for P because I can factor a P out from everything and then divide by, the stuff that's left over. So I can still solve this equation for P, even if I don't know how to write it in terms of sigma notation or as a geometric series, right? So I can still do it. But what you might want to do, Curdy, if you're still getting stuck, is again, post on Piazza, post privately and show me kind of what you have. And I might be able to provide a little bit more specific guidance in that case. If you're still getting a little bit stuck, throw it on Piazza, then that way we can talk about it there. Okay, Ariana, let me, yeah, no problem. Let me answer your question. So I thought the withdrawal action matters. For the second part of question 2, it does. That you're right, because you have taken the money out, if I recall. Let me just read the question again quickly. Yes. So the withdrawal action, Ariana, does matter for part 2 of question 2, but it does not matter for part 1, right? So the fact that the bank account is empty after June 30th absolutely does matter. But what I was trying to more answer is that for question 2, part 1, that the word withdraw doesn't affect the answer for part 1, because we could have just said, what's the value of the account on that day? But you're right, because I then withdraw all that money, the bank account is now empty, and then now that is going to affect part 2. So in that sense, absolutely, right? Since the compounding period in number 1 isn't the same. So Parneet, I don't know, maybe it's just because I'm answering the question so late. I don't actually know what that comment was for. So if you can just remind me.
I was just talking about part like assignment question number 1, part A, like where we have to find the pattern for like
Okay.
week 15. So like since it's given that after week 5, it's week 9, like the difference isn't same, like when the compounding rate is same. So like it's getting less and less by
Right.
time. So that means like our P value will change, like how we did like earlier, how we did 4P for monthly, and then will it affect like after that?
Well, I was following you right up into the end there. Yeah, can you do the last part again? So you're right, like there's a different number of payments between each compounding period, and the
So
compounding
like
periods are getting closer.
since like we are investing every week, like P dollars every week. So
Mhm.
like after week 5, since it's just like the week reduced, I guess, to week 9. So that means we just have 4, like I guess like the value of P like decrease, I guess, like we
Mhm.
don't invest. I think like the difference between 5 and 9 is less compared to 1 to 5, right?
Yep.
So like will our P value change all too, or it will just remain P, or it will become 4P or 3P?
It's up to you, and it's kind of or it's not up to you, but it depends on how you choose to write your solution. You're onto something that it seems like the coefficient in front of P does seem to be changing, because the number of compounding period, or the gap between compounding periods is getting smaller.
Yeah.
Right. So yeah, I mean, that does seem reasonable, and that is a problem, because then it's not a geometric series, right? But because there's only like 15 weeks, we can just do that one by hand. But yes, you're right.
All right. Thank you.
Curdy, yeah, I don't know about those numbers. I probably need to see a little bit more work in order to dive into it. So just take a picture of what you have and throw it on Piazza. I need to see a little bit more. And then the Zoom chat's not great in terms of like actually trying to write math, right? So just take a picture of your work, throw it on Piazza, and I'll try and take a look at it when I get a second. And then other than that, there doesn't seem to be any outstanding questions. I mean, we're almost done here. For assignment 2, question 2-2 is compounding continuously. It is compounded monthly. Yeah, everything it's compounded monthly in the second half of the year as well. But you're not given R2. You're given the continuous rate, right? The effective continuous rate. Yeah. Exactly. Yeah. So from your question, the effective continuous rate is just used to deduct the real APR. Exactly. Okay. Is everyone good? 7 o'clock? No problem, everyone. Great. No, that's Kayla. That's phenomenal. That's exactly what I want to hear. Yeah, that makes me so happy to hear. Okay, everyone, thank you so much for coming, hanging around for office hours. Hopefully we had some impact on you. And yeah, no problem, everyone. And I'll see you all on Thursday evening. And for those of you who had extra little problems to work on, please try them. And because, I really love when students create their own problems. Okay, everyone. All right. So good night, everyone. And I'll see you on Thursday.